Next, let us see the feedback effects. Feedback effects, it is there are many feedback effects. First, most importantly, effect of feedback on overall gain. Because in a control system, there are some of the components whose gains are very much essential to get the proper mathematical explanation for the working of the system. So this is the basic control system. Input or reference, output, this is the feedback through this path, having feedback path gain H, and this G, this is the forward path. This is called the forward path, and this is called the feedback path. So forward path gain is G and feedback path gain is H, and they are compared. The input and the feedback signal and error signal is generated, and that is driving the forward path through this G. Now, effect of feedback on overall gain, that is the feedback effect number 1. The overall gain of the system under negative feedback, you all can see this is minus, that means this is the negative feedback. So the overall this control system, its overall gain with this negative feedback, we have seen that it is C by R is equal to G by 1 plus GH. We have seen a little earlier. Now this G by 1 plus GH, you can see this 1 plus GH term in the denominator. It will be driving us towards explaining some conclusions, to deriving some conclusions for using this 1 by H term. The overall gain may increase or decrease depending on the value of this 1 by GH, 1 plus GH. How, if these are the explanations how this 1 plus GH term are driving us, it is driving us towards the conclusion of what it happens when the feedback is used on what it affects on its overall gain. Now, if the value of this term 1 plus GH in the denominator, since it is the overall gain of the system after using the feedback, if this 1 plus GH is less than 1, so 1 plus GH is less than 1, that means GH is less than 0. That means GH is negative. If GH is negative, the gain of the feedback path, it means it is negative. Similarly, if 1 plus GH is greater than 1, then the GH is always greater than 0 and it is positive. So, using these two explanations, we can say that if this GH is less than 0. What is GH? GH is called loop gain. So if the loop gain of this, and where is the loop in this diagram? This is the loop. This is my loop. So the loop gain is G into H, that is product of G and H. So if this loop gain is less than 0, that means the gain of the feedback path is negative, and if GH value is positive, that means when it is greater than 1 plus GH, that means GH is greater than 0. In this case, the GH value is positive because the gain of the feedback path is positive. But we are interested with gain of the feedback path negative. Why? In most of the cases for stability, we will come to this point later, that this negative feedback will be useful much more than the positive feedback for stability. So we are more interested with this first point when the gain of the feedback path is negative. Now, so it can be explained that with the use of feedback, that means when G is divided by this 1 plus GH, it is affecting the gain. That means in the feedback effect, the first point is effect of feedback on overall gain. So this is the effect of feedback on overall gain. G, it was initially G and now it is divided by 1 plus GH. So if we analyze this 1 plus GH term, we can say whether this G is getting more or this G is getting less. That means in open loop system, when H is 0, it is G. Now when closed loop is happened, with the help of this feedback, G is getting either reduced or G is getting either increased. So therefore, the effect of feedback on overall gain is accomplished by this in this manner. Now, generally in practical system, a G and H we have seen they are functions of frequency, G of S and H of S. S is complex frequency. So in control system, it is all mentioned in function of S. So therefore, the magnitude of 1 plus GH less than 1 and magnitude of 1 plus GH greater than 1, and since H is a complex frequency, that means mod G and mod H is considered for all, generally for all the analysis purpose. So therefore, the magnitude of 1 by GH is taken and magnitude of 1 by GH is taken once for less than 1, another for greater than 1. There are two cases. When this magnitude is less than 1 over some frequency ranges, in other frequency ranges it should be greater than 1, because S is having a long range from minus infinity to plus infinity. If we segregate that range in different bands, inside a particular certain band, we can see that 1 plus GH is coming as less than 1 and 1 plus GH is less than 1 means the feedback path is negative, and in another band the 1 plus GH is greater than 1 and it means that the feedback path is positive. So this explanation is correlated with the previous two. So therefore, we can say the overall gain is affected by the use of feedback in this manner. Now let us go to the